All right, we are on the third page of the review for Test 4, Unit 3. All right, the patient has an illness that is typically lasts about 24 hours. The temperature in T degrees Fahrenheit, and the patient T hours after illness is given by the following. Okay, so think about this way. If you were thinking about an X and a Y ordered pair, this is a T for time in hours. Okay, and then this is T in degrees Fahrenheit. Okay, so round all answers to 1 decimal. Gives you an idea these aren't going to be whole numbers. Look at these decimals in here. Okay, I have an A that is negative and a B that is positive and a C. All of them has decimals, so these are not going to be whole numbers anywhere. Make sure you keep track of your decimals. All right, maximum value is the question. Maximum, minimum, always go right to the vertex formula. So instead of an X, this is going to be a T equals negative B over 2A, negative B, negative 0.572 over 2 times A. Calculator. This is going to, let me check. This really does come out to a whole number. Let's see, 0.572 negative divided by parentheses 2 times negative 0.026. Sure enough, comes out to a whole number. And it's going to be positive, of course, because a negative over a negative is a positive. So when does the patient's temperature reach its maximum value? In 11 hours after the illness begins. Okay. What is the maximum temperature it's going to be reaching in 11 hours after the illness begins? What is T, capital T, when the time is 11? So put that in everywhere there's a little T. Don't need the 0 in front. Sometimes it's just good so you can see it. Make sure you're getting that 121 times that first. That should come out to, that one is a decimal. And that makes sense. You can have a temperature of 100. Apparently, when you get this kind of illness, your temperature 11 hours after the illness begins will get to 100 degrees, a little more of 100.5, so that seems reasonable. Okay. What is the altitude of the plane in meters? Just by looking at the picture, there's your right angle. That should spring to mind the Pythagorean Theorem. That's a 2. All right. This would be A and B, and that is C. Okay. So A squared plus B squared equals C squared. 200 squared is 40,000. This one's 84,100. Move this over. Showing all of my work. Getting a square, and I'm square rooting a square, so that's going to be A equals, and I'm not doing the plus or minus thing because this is a geometric shape, so the negative doesn't make any sense. So believe it or not, that is a perfect square. So that's the meters. And that makes sense. Notice that C is always going to be the larger number. So despite, it says right here, figure is not drawn to scale. So you don't know which is longer. So don't make a judgment call that way. Remember, because these sides are interchangeable as far as math goes, okay? As long as C is the hypotenuse or the diagonal, okay? That has to be over on the side. Let's look at the next one. So I'm going to make this A and this B, figure not drawn to scale, and now they want to know what C equals. So it runs directly across the field. It's nice to write the formula down. If it's required, find out from your instructor. If it's required, I recommend it highly. Excuse me. Certainly that step, create an equation with variables to find your answer, is definitely required. Okay. Showing your work at that point. Orders of operations being followed, and then square rooting both sides. 61 feet is cutting across the field, okay? Larger than the other two numbers. Excuse me. Solve this equation using the square root property. Simplify to that form. I have the square alone on one side. We're going to square root it. That takes off the parentheses and the 2. And because it's an even, it's plus or minus the square root of 85. 85 is 5. How do you know it doesn't simplify? 85 is 5. 85 divided by 5 is 17. So it doesn't have any perfect squares in it. So my final answer needs to be in this form over here. So let's move the 1 over. So t equals -1 plus or minus square root of 85. Okay, that's it for this page.